Let's do a problem in which we have to use implicit differentiation to find the equation of a tangent line. So the directions here say to find the equation of the line tangent to the curve 2x squared plus xy minus 3y cubed equals 8 at the point negative 2, 0. So here we have a relationship that's an implicit relationship, this curve that's written here. If you were to look at this curve on a graph, you would see that it's not a function. It doesn't pass the vertical line test. And if we tried to solve this for y, this relationship for y, we wouldn't be able to. So this is an implicit relationship. And so then to take the derivative, we're going to have to use the process of implicit differentiation. Now, anytime you're using implicit differentiation, you always want to keep in the back of your mind, you always want to be thinking of y as a function of x. And consequently, when you take the derivative of y, or something with a y in it, you're going to need to use a chain rule. So let me write a few quick reminders of what I just said, basically, and then we'll proceed with the problem. So, because y is a function of x, so this is an implicit relationship, but we're still thinking as y as a function of x, then we have two facts. One you already know. The derivative with respect to x of x just equals 1. Okay, that's the same as it's always been. But what about the derivative with respect to x of y? So it's not just 1. Because we're thinking of y as a function of x, this is actually either, you can write it one of two ways. You can either write y prime or dy dx. I'm going to use the dy dx notation here, but either notation that you're more comfortable with. So the derivative with respect to x of y equals dy dx. Okay, so using these two facts, let's take the derivative of this implicit relationship. Okay, so to remind ourselves that we're taking the derivative with respect to x, I'm going to start by writing it like this. The derivative with respect to x of both sides of the equation. Okay, equals derivative with respect to x of 8. Okay, and now we can proceed to take the derivative of both sides. Okay, so on the left-hand side here, the derivative of 2x squared is going to be 4x by the power rule. Now the derivative of xy squared, I'm going to put this in brackets and take it step by step. This is a product of x and y, so I'm going to need to use the product rule. Okay, so I'm going to write it out as first times the derivative of the second. So x times dx of y plus the second y times the derivative dx of the first x. Okay, so that's just the product rule applied to x times y. And we'll come back and work on that a little more in a second. Minus. Okay, now the derivative of 3y cubed. Okay, so I'm going to use a chain rule here. Okay, so I'm going to start with the power rule. So I'm going to bring that 3 down. 3 times 3 is going to give me a 9 out front. 9y squared. That's just the power rule we know. But because y is a function of x, I need to use a chain rule. And so I'm going to multiply by the derivative of y, which is dy dx. And that's all my left-hand side. Now on the right-hand side, I have the derivative of 8. Now 8's just a constant, so that's just going to give me 0. Remember that 0. If you're taking the derivative of a constant, that often kind of tricks people. Okay, so let's keep cleaning this up a little. We can work some more inside these parentheses. Okay, so inside the parentheses, I have x times the derivative of y. Okay, so y is a function of x, so the derivative of y is dy dx. Plus y times the derivative of x. Well, the derivative of x, like we said before, is just 1. minus 9y squared dy dx equals 0. Okay, so now we're finished actually taking derivatives, but we still need to actually solve for dy dx, which is what we're looking for. We're looking for the derivative. So the general strategy for this, when you're trying to solve for dy dx, is to move everything with a dy dx to one side of the equal sign, and everything without a dy dx to the other side of the equal sign. Okay, so I'm going to keep the 4x plus y on the left-hand side equals, and I'm going to move my dy dx terms over. So that's going to give me a positive 9y squared dy dx minus x dy dx. Okay, so once you've moved things around, your next step is going to be to factor out dy dx on the appropriate side. So here on my right-hand side, I'm going to factor out dy dx, which means I'll be left with 9y squared minus x. Okay, and then the last step, you simply divide in a way to isolate the dy dx. So what I'm going to have here is 4x plus y over 9y squared minus x equals dy dx. So this is my derivative. Okay, so now that we have the derivative, we can actually find the equation of the tangent line, which is our ultimate goal. So remember the tangent line, the slope of the tangent line is given by the derivative. So I have the derivative. I just need to evaluate it at the point I'm interested in to find the slope of the tangent line. So let's do that here. Slope of tangent line. So what that's going to be is going to be my derivative evaluated at the point negative 2, 0. So in this case, my derivative is 4x plus y over 9y squared minus x, and I want to evaluate that at the point negative 2, 0. So to do that, I'm going to simply plug in negative 2 for x and 0 for y. So 4 times negative 2 plus 0 over 9 times 0 squared minus negative 2. So that's going to give me a negative 8 on top, and then on the bottom, it's going to be 0 minus negative 2. So that's positive 2 overall. So positive 2. And then that's going to give me negative 4. Okay, so the slope of the tangent line is negative 4. Okay, so actually now we have everything we need to write the equation of the tangent line. We're already given the full point, negative 2, 0, and we have the slope, so we can use point-slope form to write the equation of the line. Okay, so my point, if you recall, was negative 2, 0. Okay, so point-slope form. I do y minus the y coordinate, so y minus 0, equals the slope, negative 4, times the quantity x minus the x coordinate, so x minus negative 2. So that's y equals negative 4 times x plus 2, and I can distribute that negative 4 if I want, and write this as y equals negative 4x minus 8. And that's the equation of the tangent line. And if you have any sort of software that's capable of graphing implicit relationships, you can actually check this. So I'll pull that up for you very quickly. So this just shows the curve here, this implicit curve, and then the tangent line, which indeed looks like a tangent line at negative 2, 0. All right, so this is how you find the equation of a tangent line if you have an implicit relationship.